This is problem number 6 for section 2.3. In this problem it says, for the given function f of x and values of L, C, and epsilon greater than 0, find the largest open interval, so we're looking for the largest open interval about C, on which the inequality absolute value of f of x minus L less than epsilon, so meaning our difference in the y values have to be less than our tolerance epsilon. Then determine the largest value for delta, so we're looking for that largest delta value, which is the tolerance of our x values, such that the definition of a limit holds. So 0 less than absolute value of x minus c less than delta implies f of x minus L is less than epsilon. So what are we really trying to do in this problem? Well, we start with f of x equals 1 over x. And when we graph f of x equals 1 over x, let's go ahead and go to the y equals, clear this out, and we're going to say 1 over x, graph it. You're going to see that this rational function looks like so. So we'll draw the rational function here. And our goal is to look at this c value, which they tell us the c value is 5. Let's just put c value of 5 right here. And our goal is to find an open interval, so for our x values, right, that when we draw them up to the function, they give us a epsilon, right? Remember they say epsilon, that is essentially less than 0.005. So this in here is going to be 0.005. So will this be 0.005? And remember this L is 0.2. So L equals 0.2, and that's this spot there. So hopefully that makes sense what we're trying to do. We're trying to find what's the largest interval from this spot to this spot that will keep our tolerance for E at 0.005. So how do we do this? Well, we need to start with what our tolerance is and work our way backwards to find the x values. So we need to start with this epsilon piece, which is the absolute value of f of x minus L less than epsilon. And let's plug in our information that we know. So we have the absolute value of 1 over x minus 0.2 is less than the epsilon, which is 0.005. And I always like to start these absolute value inequalities by saying that the absolute value of 1 over x minus 0.2 equals 0.005, and at the end I'll use the number line to deal with the inequality. So when I say that that equals 0.005, that's 1 over x minus 0.2 equal 0.005, or 1 over x minus 0.2 equals negative 0.005. Add the 0.2 over, and you end up with 1 over x equals 0.205, or 1 over x equals, when you add that over, you get 0.195. Now essentially, if we just flip each of these, we can write this as x technically over 1 equals 1 over 0.205, and that's going to give us a number there. And then we do the same thing here. This is x equals 1 over 0.195, and we'll get some sort of decimal there. Let's do 1 divided by 0.205, and we get 4. I don't know what they're going to want us to round it to, so I'll just do thousandths place, 878. And then this one would be 1 divided by 0.195. I get 5.128. So this part is 5.128, and this part is 4.878. Now, we need to check this on a number line. So if I draw the number line right here real quick, and essentially, I mean, this is already on a number line, so we'll put 5 in the middle. This is 5.128. This is 4.878. I'm just going to double check that our solutions run between these 2 points. The less than sign kind of gives it away, but we can check it anyway. So we plug in 5, and we get 1 divided by 5, which is 0.2, minus 0.2, that's 0. Well, 0 is going to be, when we take the absolute value of it, will be less than 0.005. So our solutions run between these 2 spots. So we're going to say 4.878, comma, 5.128. This is our open interval for part A. Now part B, I need to figure out what delta has to be. Well, we know the difference right here between these two, the difference between there, so we're going to say, well, I don't have anywhere to write it, but our difference from C to this point here, so we'll just do the absolute value of 5.128 minus 5. That's just going to give you 0.128. And then we do the absolute value of 4.878 minus 5. That's going to give you that'd be 0.122. And so because we get 0.122 for this one, and this is a smaller value, so this is a smaller value in here, 0.122, than 0.128 is here, this has to be our delta value. So we're going to say the delta value is equal to 0.122, and that's our tolerance for delta that gives us this epsilon value, which stays within 0.005.